everybody, today we're going to focus on how is it that we can solve systems using substitution. So solving systems of equations with substitution. We are going to cover exclusively systems that have two variables and two equations or 2 by 2. So for us to use substitution, we have to focus, or we are going to focus, in 3 ideas, 3 simple ideas. Idea number 1, isolate. Idea number 2, substitute. And idea number 3, solve. Okay? So this is the way that it works. You have 2 equations. Here I have 2x plus 6y equals 24, and my second equation is considered y equals -5. So the first thing that I need to do is isolate, which in this particular case, the isolation is done already. Y is already by itself on one side is isolated and is equals -5. So that's step number 1. Step number 2, we need to substitute, which means that we're going to take our first equation, 2x plus 6y equals 24. And we are going to substitute. Substitute what? Substitute y, because we already know that y equals -5. So the way that this is going to be is 2x plus 6, and instead of y, I'm going to put a -5 equals 24. Okay, so we finish our substitution. That's all that we needed to do. Remember, always use parentheses when you replace the letter for its number or substitute. So now we're just going to solve, meaning I need to know what x means. So now I can solve for x. How is that going to look like? So first, I need to multiply this too, because multiplication first. 6 times -5, -11. I still have my 2x equals 24. Now I need to cancel my -11 with a +11. And then 2x equals 35. And then at last, we're going to cancel the 2, divide by 2, divide by 2. So this is going to be 35 over 2. So remember, every single system has a solution that is x comma y. So in this case, my x is 35 over 2, and my y is -5. This will be my solution. So remember, this is my x, this is my y. I was given that from the beginning. So here together is my solution. So now we're going to look at a different problem. We are still going to follow our 3 ideas. First, isolate, then substitute, and at last, solve. Okay? So for our first step, we already have one of our variables isolated, y. And now we're going to focus on the substitution. So we're going to write our first equation. 2x plus 3y equals 21. And then what I'm going to do is, since I already know the y value, I'm going to substitute the y for its value, which is -3x. And I know that this might look like things are going to be more complicated, but you'll see. 2x plus 3, and remember, parentheses, and then my y value, -3x equals 21. Okay, now we are ready to start solving. In this case, my variables are x's, so I know that I'm going to have to solve for x. So we're going to start with this multiplication. 3 times -3, that's going to be -9x. And I'm going to drop my 2x equals 21. Now these two are like terms, so I can combine them. 2x minus 9x, -7x equals 21. And at last, cancel the 7, divide by negative 7, divide by negative 7. So 21 divided by negative 7 equals negative 3. So if I want to find my solution for any system 2 by 2 or 2 variables, 2 equations, I need an x, comma, y. So in this case, my x is the one that I found, negative 3. And my y, I still cannot find it because this is not a number. So what am I going to do? We are going to substitute one more time. Meaning, if I already know the x value, I can plug in my x value there and I'll tell you what the y value is. Okay, let's do that substitution. So this is y equals negative 3 and then x. And what was my x value? Negative 3. So remember, we are following this equation. So now we can solve. Y equals negative 3 times negative 3, 9. So here is my x value, and now I find my y value. My y value is 9. So my solution is negative 3, comma, 9. Okay, here we have another example. We're still using our 3 steps, which is isolate, substitute, and at last solve. Okay, so here we are going to start with isolate, and one more time, my variable y is already isolated. So we can say that that step, it's already been done, okay? So now we are going to substitute. So I'm going to take my first equation, which is 2x plus y equals 8. And in here, I am going to substitute the y because I know that y is negative 2x minus 6. That was being known from the beginning. So this is going to look like 2x plus and y. And here we're going to substitute the whole y value, which is negative 2x minus 6 equals 8. And now we just need to worry about solving. In this case, solving for x, because that's the variable we have in hand. Okay, so parentheses first, we have a positive 1 multiplying negative 2x. So that is negative 2x. And that is going to remain as a negative 6 as well. And we're going to drop our 2x from right here. Equals 8. Okay, so let's combine like terms. This too. So 2x minus 2x, they cancel. And we have left negative 6 equals 8. Remember that every time that you are solving and you end up with no variables at all, it's because you have a special case. What kind of special case do we have here? We have negative 6 equals 8. This is not true. When we have a not true statement, it's because we have a no solution equation, or in this case, a no solution system. In other words, these two equations, if we graph them, they're going to be parallel lines to where they never intersect. That's why there's no solution. Okay, let's do our last example. When you end up with a not true statement, in this case, negative 6 equals 8, this is not the same number. This is a no solution system. This is our last example, and again, we're going to use the same steps. Isolate, substitute, and solve. This one might look a lot more complicated. Okay, so let's see. Isolate, is one of my variables isolated? The answer is yes. Look at x. X is isolated in my first equation. So again, we can say that our first step is done already. Okay, now we're going to substitute. So we're going to use, in this case, the second equation because that's the one that is not isolated. So I have x minus 1/2 y equals negative 2. And now I'm going to substitute x. Why x? Because x is the one that is isolated, so x is the one that I know its value. Don't forget parentheses to substitute all the time. So this is going to be 1/2 of y minus 2. All this is my x. All that is my x. So this is just that. And then I'm going to continue my equation. Minus 1/2 of y equals negative 2. So here I'm going to start with the parentheses. There's nothing that I have to do to get rid of the parentheses. So that's 1/2 of y minus 2 minus 1/2 of y equals negative 2. So we're going to start with the like terms. 1/2 of y minus 1/2 of y. These two are going to cancel. And what we are going to have left on this side at least is going to be negative 2 equals negative 2. So again, we end up with no variables. What does that tell me? This is a special case. The question is which special case? I have negative 2 equals negative 2. This happens to be a true statement. And what does that mean when I have a true statement? I have a 5 equals 5, a 10 equals 10, or in this case, negative 2 equals negative 2. It means that this is an infinite solution system. So I want to clarify that one more time. When you end up with a statement that is true, in this case negative 2, it is equals to negative 2, this is infinite solution.